Hello and welcome back to Mr. Powers Teaches Algebra. Last video I made, we're talking about what? Adding rational expressions. It's the rational expressions stuff. And we did an example. We did a particularly long example, although there are longer ones, to be fair, but it was pretty good. It's pretty long. Now, let's do a few more much simpler examples. I'm thinking we're going to do, I guess we'll do two or three more examples just so you guys can see some more if that's what you want. I see a video like this as completely optional. If you understood the how-to video and there was one example there, you don't need this. Absolutely not. But if you're not good with the words like factors and you're not, then yes, you need to do this one more. Or you just like to see lots of examples. Everybody's different. So let's move on. Let's do it. First example. 4 over, I think we'll do that. Okay. Try again. 4 over 6x squared minus 1 over 3x to the 5th plus 5 over 2x cubed. All right. So first things first. If you guys remember my strategies, the way I like to do things is I like to factor these first. Now, the first one is not factored. Our first term, our first expression is not factored, but the others are factored completely. So that's fine. The numerator we don't need to factor, just the denominators, because remember, that's what we're worried about. Is we're trying to get a common denominator in order to be able to add these up. So we have 4, and also I like to do this. Get rid of that subtraction. If everything's adding, it's easier. So I like to make it all adding. So 4 over 2 times 3x squared. Let's see here, plus negative 1 over 3x to the 5th. And then, what else? Plus 5 over 2x cubed. Okay, so the nice thing here we'll notice right away is that there's only numbers and x's. This is going to be really easy to get a common denominator. So I'm looking at, first off, I guess, what am I multiplying, right? I got a 2, a 3, and x squared here. Does this denominator have something this one doesn't? And yes, it does. This one has x to the 5th. I have a 3. I don't have x to the 5th. I have x squared. It has 3 more x's here. I need to add 3 x's over here. So x times x cubed times x cubed. And then now this first denominator has everything the second one does. Okay, great. Let's check it with the third. There's a 2 in this denominator. Is there a 2 in my first one? Yes. X cubed? Yes, I got an x cubed. I'm good. This one's done. And this would be my common denominator. 2 times 3 times x to the 5th. So now it's the same thing. What is this one missing? Well, let's go. There's a 2 here. There's no 2 here. I definitely need to go times 2 times 2. There's a 3 here. There's a 3 here. Great. There's x to the 5th. There's x to the 5th. Good. Over here, same thing. 2. Got a 2. X cubed. Yeah, x cubed within this x to the 5th. I'm good. Now, the last denominator, get it the same. 2. Well, again, there's a 2 here. Got that. 3. No 3. Need the 3. All right. X to the 5th. Do not have that. I only have 3 x's. So I need x squared. So times 3x squared. And then these are all the same now. 2 times 3 times x to the 5th. 2 times 3 times x to the 5th. I'm good. I got a common denominator. Let's go ahead and multiply these numerators out all over the same denominator and then combine like terms, and we're done. It's too easy. So the first one's 4x cubed over, I'm just going to write 6x to the 5th. This one's so simple, I'm just going to leave it 6x to the 5th. And then we have a negative 1 times 2, so it's a negative 2 over 6x to the 5th. And then 3 times 5 is 15. So this is 15x squared for my numerator, all over, again, 6x to the 5th. Combine like terms. Now we can do it. So let's see, x cubed. No x cubes here. So that one's done. Negative 2, there's no numbers here. 15. There's no combining like terms. Let's just put it in order. Highest power first. That's what we like to do. So x cubed first, 4x cubed plus 15x squared minus 2 all over 6x to the 5th. And this numerator doesn't look like anything I could factor, and even if I could, who cares? I'd need a common factor because I'd want to factor something. I would want to cancel something with my denominator. My denominator only has monomial factors. So unless I have a monomial factor up here, which I don't, it doesn't matter. I'm done. This is it. Piece of cake. Example 1, done. That's about as easy as they get. Now, what is another one we can do? I want to do, let's see here. Let's do this one. And then I think we only really need one more. I think we should be good. So 4 over, so here's our next example. 4 over y plus 2 minus 1 over y plus 1. Let's look at that one. But if there are more examples you would like to see, of course, we'll do those in our office hours, in our class meetings, all that fun stuff. So here we go. The nice thing about this one is it's all the denominators are factored already. I don't need to factor them. I just need to get them all the same. So it's the same idea. It's like, okay, well, I got a y plus 2 here. Who cares? There's a y here. I need a y as a factor over here. So I need to multiply this times y, whatever due to the bottom. I got to 2 to the top. And I'm done. The 1 is really 1 over 1. We don't need to worry about a denominator of 1. Who cares? Okay. So now what? We have this denominator. Let's try to get this the same. Well, this y, let's compare it with this first denominator. There's a y plus 2 here. There's not a y plus 2 here. I definitely need to multiply this by y plus 2, whatever to the bottom, must do to the top. And then we're on this 1. Well, 1 is a trivial factor. It's missing everything. We need all of it there. So what do I need to add to the 1? Well, what these other two are, y times y plus 2. So y times y plus 2, and multiply the top by the same thing, y times y plus 2. And then we just need to multiply the numerators and rewrite our rational expression. So we got 4 times y here, 4 times y, over, I like to put the y in front, so y times y plus 2, minus, and I forgot to distribute my minus in, so we'll just be careful here, 1 times y plus 2. So I got y plus 2 over y times y plus 2. And then I got my plus 1 times y plus y times y plus 2. So it's just y times y plus 2 over y times y plus 2. That makes sense. Remember, it was a 1, so this should be the same here. And now we can go ahead and combine like terms. So again, I want to combine like terms. I got this minus out here. I got to take care of it now. So it's like plus negative 1 times y plus 2. I got to distribute that negative in other words. So it's really negative y and a negative 2. Now I can combine my like terms. Let's see. Oh, you know what? I should have multiplied this out. I don't know why I didn't do that. Let's go ahead and multiply y times y plus 2. And what do we get? We get y squared plus 2y. That makes more sense. So now my y squared, well, there's only one y squared. So down here now, we get y squared, and then my y's. Let's go ahead. We'll do the highlighter again. I got a 4y, a negative y, and a 2y. So let's see. 4y plus 2y is 6y minus y. It's 5y. So that's going to be plus 5y. And then we got our numbers to deal with. That's going to be negative 2, and that's it. Just the negative 2. So, all right. Easy. So minus 2 all over y times y plus 2. Now I can see, again, now we just want to see, can we simplify this? Right? Our first section in these rational expressions was simplifying. Can I factor the numerator and cancel out something? So is y plus 2 a factor? I know y isn't, but is y plus 2 a factor of this? And we can just double check, you know. Let's, if we had y squared plus 5y minus 2, our only chance is if it's a y and a y, and then a 2 would have to be a 1 and a 2. And I'll tell you right now, there's no way, whatever these are, if they're minus, if they're plus and minus, it doesn't matter, because 1 times y is y, 2 times y is 2y. There's no way to add or subtract those to get 5y. So this guy doesn't factor. We are done. This is as simple as it gets. And that is it. So those are a couple examples. And yeah, took about as long as I thought it would. 12 minutes. All right. So these do take a little bit of time, but that's how it goes. So I hope you found this useful. Until next time, enjoy doing math.